Reporting from downtown Portland, Bridget Chavez, Fox 12 Oregon.
Hello, Rachel. Can you hear me?
Yes.
Okay. So would you like us to quickly go over the PowerPoint and then do the homework?
Sure.
Depending on how much time you have. So I will try for us to really go quick on the PowerPoint. So you have a TI-83, 84 calculator?
84.
Good, that's good. So we are first going to learn about the empirical rule. So the empirical rule says that a normal distribution has the following properties. 68% of values are within the first standard deviation. So you see between the first standard deviation, you have 34% to the left, 34% to the right. And between the first and the second, you have 13.5. Between the second and the third, you have 2.3.5, and you have you have 0.15% to the tail, everything which is below the third standard deviation. So this can be useful in answering one of the questions that is actually, I think, the first question on your quiz. This is an example for it. In this example, we say that the plane life of a sunshine radio is normally distributed with a mean of 600 and a standard deviation of 100. What is the probability that a radio selected at random will last from 600 to 700? I'm going to change the screen to do it on, to use a whiteboard. So here, we have a normal distribution with a mean of 600 and a standard deviation of 100. One standard deviation above the mean will take us to 700. Two standard deviation above the mean will take us to 800. Do you have an idea how I'm getting the numbers? The standard deviation is 100. So if you move one standard deviation above the mean, you get to 700. Two standard deviation, you get to 800. If you get one standard deviation below the mean, you get to 500. If you get two standard deviation below, you get to 400, and so on. So we will recall that based on the empirical rule, you recall empirical rule, it says that within one standard deviation, there are 68% of values, 34 to the left, 34 to the right. So if we are asked, what is the probability a person selected at random will be between 600 and 700? That will mean that that person is on the first standard deviation. Sorry for this. Yeah. So between, that we mean that score is here between 600 and 700, and that is 34%. The answer will be 34%. So this is 34%. Sorry for the writing. So if it was between 600 and 700, we will add 33.5 to 34 to have 47.5. If the score was above 800, we will take that there is 50% to the left, 50% to the right, and within two standard deviation, we have 47.5. So above 700, above 800, we are above the second standard deviation, which is 50 minus 47.5. The mistake students always have is to think that everything above the second standard deviation is 2.35. No, above second standard deviation is 2.5, but between second and third is 2.35. So in the quiz, you will be given the mean and the standard deviation. Most problems in chapter 6, you will want to know what is the mean, that's the average, what is the standard deviation. Okay, so let's get back to the PowerPoint and continue with the next topic. So I am back to the PowerPoint. So you can go over the PowerPoint to understand why we have the answer to be 0.34, which is 34%. So the standard unit is the standard measure of a normal distribution. Once you have the mean and the standard deviation, you can compute the z-score, which is called the standard score or the raw score, or the z-score or the standard score of any distribution. That z-score here is here, x minus mu over sigma. It has the property that its mean is always 0 and its standard deviation is always 1. When you don't have a calculator, you need the standard score because a standard distribution table is always available. And with the standard distribution table, you can always find a probability above a normal distribution by standardizing the equation. So, but when you have a TI 8384, whether it is a standard score or a regular variable, your calculator will help you to answer questions about probability. So let's look at this question. A pizza parlor franchise specifies that the average or the mean amount of cheese on a large pizza should be 8 ounces, and the standard deviation is 0.5 ounce. An inspector picks out a large pizza at random in one of the pizza parlors to find that it is made with 6.9 ounces of cheese. Assume that the amount of cheese on a pizza follows a normal distribution. You will have that statement in all the problems. Essentially, you want to know what is the mean, what is the standard deviation. If the amount of cheese is below the mean by more than 3 standard deviations, the parlor will be in danger of losing its franchise. So we want to know how many standard deviation is 6.9 away from the mean. That is what we also call the z-score. To know how far 6.9 is away from 8, you will subtract 8 from 6.9 and divide by 0.5. To know the number of standard deviation it gets away from the mean. So that's what we will do here. We'll find the z-score, which is subtracting the mean from the score and dividing by the standard deviation. The mean is 8. The raw score is 6.9. When you do that operation, you get the z-score of negative 2.2. So sometimes you will have to do the inverse problem. This is in case you don't have a calculator. That's why I asked you if you have a calculator. With a calculator, things will go much easily, and I require that calculator. So when you don't have a calculator, it is not, you cannot go fast. You will have to be doing these equations, which you don't need. I will teach you how to use your calculator to get a score when you have a z-score and a probability. So when you have a z-score, which is a normal distribution, it also follows the empirical rule because it is a normal distribution. Within 1 standard deviation, you have 68%. Within 2, you have 95%. Within 3, you have 99.7%. And so we can use the table to find the probability, but because you have a calculator, I don't want to waste our time going onto that table. So find the area under the standard normal curve to the left of z equals to -1. You can see this table. You want the blue area. That is the left of z is that blue area, okay? It is also expressed as the probability that z is less than or equals to -1. Now, get your calculator and let's do that. So set your calculator on. We will work on it several times and then you will get used to it. So with your calculator, you go to second function. You see second to the up left here. I don't know if you can see. Can you see my screen?
No, I cannot see that.
Do you see my screen?
I can see your screen, but I can't see your calculator.
Can you see?
Okay, now I can see it, yes.
Okay, so this is the second function. The
Oh,
blue
the
here,
second?
that's second.
Okay.
Do you see second? We will need it. Then you will see VARS here.
Okay.
We will need it also.
Okay.
These are the two we will need for now. So you press second function, then VARS, that is for distribution.
Okay.
Then you will see normal CDF. CDF stands for cumulative distribution function or cumulative density function. So you press that second and you have CDF. Can you do that with your calculator?
Yes.
So what do you see on your calculator? Okay, you see, you will have, let me use exactly the same calculator as you. Let me see, I have one here. So when you do that, you are going to see lower value, upper value. Is that what you have?
Yes.
Okay, your lower value by default is -1, 10 raised to power 99. So the lower value is sometimes given, but when you see z is less than -1, it means the lower value is -infinity. So for that value, we can take any very large negative number. If you don't see anything there, the lower value, when I write z is less than -1, it means it can go really below to -infinity. So that is what that number stands there for. So upper value here is -1. So this is a standard distribution. Your calculator by default is on standard distribution. So the mean will be 0 and the standard deviation is 1. So whenever you have a equation with standard deviation, you just use mean 0 and standard deviation 1. Now, I enter -1 to upper. -1 is there is a parenthesis below near the point, the last row of your calculator. You will see negative between two parentheses on your calculator. So the last number, the last key of your calculator. Do you see my calculator? Up, this is not exact. I have changed my calculator. Can you see?
Go down. Okay, and then like face it more towards the camera. Okay.
Look at your calculator. What about that? Look at your calculator.
Okay.
So on the lower right side of your calculator, the lower right, where your right hand is, you will see negative and 2 brackets.
Okay.
Okay. That is how you put the minus when you want to enter a negative number.
Okay.
So if you are at upper value, you put that negative and 1. Do you see -1 on upper?
Yes.
Okay. Then you press enter. You press enter twice. So what value do you have?
Oh, I don't know why I didn't get a value. I pressed enter and it bumped me down to the mean.
Good. Press enter again. If you had a different mean, you will change it from 0 to the new mean. And then it will take you to standard deviation. Then press enter again until when you are on paste, you press enter finally.
Okay.
Okay, then you will see normal CDF and those numbers. Then press enter again.
Okay, I got 0.
0?
0.
Okay, you did something wrong. Let's start over. Just be patient, you are going to learn. So you press second,
Okay.
VARS,
Okay.
then 2, you press 2.
Okay.
That 2 is normal CDF. I think the first time you press normal PDF. Now it's normal CDF. So lower value is -1 E99. Press enter.
Okay.
Now type negative, that is the bracket negative,
Okay.
and 1, and you press
Okay.
1. Then press enter, then
Okay.
enter again,
Okay.
then
So
enter.
0.1586.
Good. So if you look at my screen now, you can look at my screen. For those who have table, this is how they read the table. You will look at -1.00. The table have the Z value on the column, the first column, and then the decimals on the subsequent columns. So what you will do is that under 00, -1 is -1.00. You will see 0.1587. This is on the screen. Do you see this number?
Mm-hmm.
That is what you got with your calculator. It was difficult with the calculator. I don't want you to learn both. I want you at least to see how to read the table. Okay, this is for those who are not using the table, who are using the table. In this class, we don't have the time to learn table. We use calculator or Excel. So now look at this question. Find the area to the left of Z equals to 1.18. Let's do this together. Z left. You see how the blue area, the shaded area is the left, is what is below 1.18. So let's go together again. Second function, VARS, then 2 is still left. So we will leave the -1 E99, enter. Then we enter 1.18. Then you can just click enter until you see the answer.
Negative or 0.8809.
Good. So you can see the answer on my screen here, 0.8810. So let's just do, for the purpose of learning, the area to the right. Let's do area to the right. Area to the right means is greater than 1.18. So you can just do 1 minus 0.881. Let's just make it 0.881. If you have area to the left, area to the right is 1 minus area to the left. You see, when you divide, the area to the left is the blue area. Area to the right is 1 minus area to the left, because the total area under the curve is 1. So then you get it. You will have 0.119.
Yes.
Now let's use our calculator as if we did not know area to the left. So we will do second function, VARS 2. Now is area to the right. So it means it will start with 1.18 and go to infinity. So we will remove -1 E99 and put 1.18. Press enter. The upper value is now going to be a large value. I don't want to take time to teach you how to write that 1 e to the 999. I would just say write 1 billion or a very large number. So that will represent our infinity. If you don't know how to type -1 E99, just write -1 million. It will always work. So we are going from 1.18 to a very large number. Then you keep entering, typing enter, 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 enter until you see the answer.
0.1190.
Good. So that is the area to the right. If you now want the area between two numbers, let's say we want the area between -1 and 1.18. If we want the area between -1 and 1.18, we will take the area. You can use your calculator, but if you are given those two areas, it will just be the difference between the area. Let's use calculator to do that. We will do second function, variables or 2, and then we want the area between -1 and 1.18. So you have 1.18, we want to type -1. Remember, negative is bracket negative. -1 is the lower value. 1.18 is the upper value. And you just enter.
0.7223.
That is the area. So whenever you are dealing with the z, the mean is 0 and the standard deviation is 1. So you will answer question the way we are doing. So now, we have answered some of these questions already. Area between, area above. That's why I am skipping. So now 6.3, we want to answer a question about a regular normal distribution. What we have done so far was about standard normal distribution. So these are the instructions in case you forget. In slide 32, I gave you the instruction how to find the probability that a value is between two numbers. So let's look at this example. Let X have a normal distribution with a mean of 10 and a standard deviation of 2. Find the probability that an X value selected at random from this distribution is between 11 and 14. So what we are going to do is we go to second, VARS, two is between 11 and 14. So the lower value is 11. The upper value is 14. And then what is the mean again?
10.
10. The mean is 10. Thank you. And the standard deviation?
2.
2. So what do you get?
0.286.
Great. So when you have a question about a normal distribution, you can use your calculator. But you can also use the regular formula. You can skip those ones because you have a calculator, so you can use your calculator. Now, sometimes we have questions about the inverse normal. So far, when we have X or Z, we can find the probability. In some instances, you are asked to find Z when you are given the probability. So we have used the score to get the probability so far. The inverse question is, if you have the probability, how do you get the score? For example, if I ask you, what is the Z value so that the area to the left of Z is 0.05? What is the Z value so that the area to the left of Z is 0.05? I want you to know that if the area to the left is 0.05, then the area to the right is 1 minus 0.05, which is 0.95. Your calculator can only answer questions about area to the left. So if somebody asks you, what is Z? So the area to the left of Z is 0.95, for example, or no, I wanted to say right. What is the Z? So the area to the right of Z is 0.05. They gave you area to right. ask yourself what is area to left. Once you know area to the left, you will use your calculator to get the correct answer. So let's start with area to left of Z is 0.05. What is Z? Suppose we are looking for that. So now you go to your calculator and you go second function, VARS. Now you will go to 3. You see 3, inverse normal. You press 3, inverse normal. When they say area here, they mean area to the left. Even your table in the book is always considering area to the left. That's the cumulative area. So we want 0.05. You type 0.05 there. If it is Z, you will leave the mean 0 and the standard deviation 1. If you are asked what is Z, so the area to the left of Z is 0.05, you will leave the mean as 0 and the standard deviation as 1. So you will enter until you get the answer. Can you try that?
1.08.
No. Let's do it again. The area is 0.05, okay? And that is area to the left. So press second, VARS, and then 3. What do you see?
I see area.
And what did you type there?
0.05.
Okay, just press enter until you get to the.
Oh, negative 1.64.
Yes, I could tell you without checking that your answer was wrong because it was positive. If you are to the left of -1, that means you are to the left of 0. The area cannot, I'm sorry, if the area to the left is 0.05, it is a negative number because the middle of a standard distribution is 0. So if the area to the left of a number is 0.05, it is really at the tail. That means the Z value corresponding to it will be negative. Okay? Let's come back to our problem here. In this problem, we will want to find the inverse normal for a regular distribution, not standard, a regular normal distribution. So Magic Video Games sells an expensive video games package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the computer fails during the guarantee period. You know the idea of guarantee when you buy something, right? So we want to use that to determine how long should be the guarantee period. So the research department has done tests that shows that the mean life for this computer game is 30 months with a standard deviation of 4. We want to write that down because I will move to the whiteboard to explain. So it tells us here that the mean is 30 and the standard deviation is 4. So the computer life is normally distributed. How long can the guarantee period be if management does not want to refund the purchase price on more than 70% of the Magic Video package? So I'm going to change the screen, go to the whiteboard and explain before we come back to the PowerPoint. So we were told that the lifetime of a computer of that video game is normally distributed. So the time will have a normal distribution, which is of this shape. Okay? So that means starting from the beginning here, the computer lifetime we have an average of 30 months. We want to set a time limit within which if the computer get bad, let's call this time A, that if computer get bad before A, like before 20 months or before 10 months, they will refund you the full purchase price. So you want to put that value at the beginning here because that is the guarantee period. It's early enough. You don't want it to exceed 30 months because 30 is the average lifetime. So the computer lifetime will start from somewhere 0, the day the computer was purchased, to the date when guarantee period expires. So the company does not want to refund more than 7%. So 7% is this area. So that is, this area is 7%. So the probability that a computer will get bad within the guarantee period is 7%. That's the meaning of that question. What should be A? So this is an inverse problem because we are given the left area. Sometimes you are given the right area. If you have the right area, determine the left area by subtracting the right area from 1. You will get the left area. Inverse problem, always try to get the left area. So let's remember that the standard deviation was 4. And the mean is 30. So let's go back to our calculator. We want the inverse normal for a distribution with mean 30 and standard deviation 4 when area to the left is 7, 0.07. Okay?
Mm-hmm.
Now, so whenever you have a problem, you want to translate it in probability as simple as possible. We want to find the value of x so that the area to the left of x is 7%, given that the mean is 30 and the standard deviation is 4. So we will go to second function, VARS, and 3 for inverse normal. Second, VARS 3. What is the area?
Would it be 0.07?
Great. Area to the left, 0.07. What is the mean?
30.
And the standard deviation?
4.
Okay. You can now find
24.096, blah, blah, blah.
Great. Was it that difficult?
What?
Is it that difficult?
No.
Yeah. So when you have problem, just tell me when you have time. We will meet like this and discuss it. If nobody, because I started having Zoom class and nobody show up, so I told you, if you have a question, just let me know. Like on chapter 7, you can tell me when you have 1 hour. We just go over it like this. And then wherever we stop, we stop. If you are tired, you can stop. You tell me that you want to go and we stop. Okay.
I'm actually taking like 13 credits right now, so this is just a lot.
It's a lot.
Yeah.
No, it's a lot.
It's a lot.
I understand. Yeah, anyway, when you have the little time, just let me know. We can discuss if you have a problem. Because even me, I would find it difficult to just read. Some people can just read and understand. But if somebody is explaining to me, it's much easier. So we have 24 is the answer. You can see it here using your calculator. So now more explanation is because I'm assuming students may not have calculator. Though I explained, but that is not an excuse for you not to do well because the calculator is required for the class. Otherwise, we will spend a lot of time doing this mathematics, these computations. Okay, if you are doing the computation manually, you will get the answer 24 months. Okay, 6.4, I will skip 6.4. I will explain. There's nothing to do on 6.4. Okay, we discussed a normal distribution in 6.3. In 6.4, we are now saying that we can have some specific type of normal distribution, like the normal distribution of sample mean. This is obtained by taking a random sample of a size n. If you take a random sample of size n and compute the mean, the sample mean is considered a normal distribution if the population was normal or the sample size is at least 30. We are going to say this a lot and you will remember. So we are going to get to, I will skip this, not so that we don't. So the sample mean is a normal distribution if either the population is normal or the sample size is at least 30. The mean of the sample mean is the same as the mean of X. The problem is with the standard deviation. When I'm doing this, do you see how I'm moving the cursor? The cursor? This is the standard deviation for the sample mean. Is sigma, the standard deviation of X, divided by square root of n, when n is the sample size. Remember, I told you that for each normal distribution, you want to know what is the mean and what is the standard deviation. For the standard normal distribution, the mean is 0 and the standard deviation is 1. For a regular normal distribution, they will give you the mean and the standard deviation. Now, if you take a bunch of observation from a normal distribution with mean mu and standard deviation sigma, you can take the sample mean, and the mean of the sample mean will be the mu, and the standard deviation will be sigma over square root of n. So whenever you are asked to find the probability that the average of a certain number is less than, greater than, or between, that means you are dealing with the sampling distribution of sample mean. What you want to do is to adjust the standard deviation by dividing the provided standard deviation by square root of n. So we are going to look at some example. I've already explained most of this to you. Let's look at this example. Suppose a team of biologists has been studying the Pinedale children fishing pond. Let X represent the length of a single trout taken at random from the pond. This group of biologists has determined that X has a normal distribution with mean 10.2 and standard deviation 1.4. This is the mean. Mu is 10.2. You can write it because I will go to the next slide. And standard deviation is 1.4. What is the probability that a single trout taken at random from the pond is between 8 and 12 inches? Here is a single trout taken at random, weigh between 8 and 12. Let's do it before we check the answer. So go to the calculator. We have the mean and the standard deviation. What is the probability that the weight is between 8, the size is between 8 and 12? So we will do second, variance or variables, I'm sorry. And then we will go to 2. This is normal CDF. When you say probability between, we go to 2. Then, the lower value here is what?
8.
8. The upper value?
12.
The mean?
10.2.
The standard deviation?
1.4.
1.4.
0.8426.
0.8426. We are not going to get the same answer because this is calculated without rounding up anything using, this This is calculated with rounding up, I'm sorry. Our calculator gives a most accurate result because it does not round up. So sometimes you will see some slight difference like this one. So the answer is 0.8433, which we can write as 0.84. Now, look at the next question. This is where the sampling distribution of sample means comes in. What is the probability that the mean length of 5 trout taken at random is between 8 and 12? The difference between the two questions is that the first one was a single trout, the regular distribution. Now, this second question is that you have 5 trout and you want to compute the mean and determine that their average length is between 8 and 12. What we want to remember is that the mean is the same, but the standard deviation will change. So to find the standard deviation, you take the standard deviation of the regular distribution and you divide it by square root of 5. Maybe I should teach you how to use your calculator to do that. You will do 1.4 divided by, you see division, then press second function. To get square root, you press second function and x squared, and then you type 5. So you have 0.626, which you can see on the screen there as 0.63. That is the standard deviation for the sample mean. So the question was, what is the probability that the sample mean is between 8 and 12? So we now use our normal distribution calculator, second function, VARS, 2. The lower value is what?
8.
8. The upper value?
12.
12. The mean?
10.2.
10.2. The mean remain the same. Now the standard deviation will change to what we just computed.
0.63.
0.63.
0.9976. So
the probability that the average size of 5 trout is between 8 and 12 is 0.9976. Let's look at the answer here.
Poor baby.
So half the answer is 0.99. You have a good calculator because your calculator asks you for lower and upper. The reason why I'm writing this is because some of the calculator don't ask lower, upper, and you have to write 8, 12, 10.2, 0.63. That is when you are using TI-83. So you have a better calculator. So now that is it with the distribution. Let's do another example. Would you want to do another example? Okay, let's look at this one. A certain strain of bacteria occurs in all raw milk. Let X be millimeter of milk. The health department has found that if the milk is not contaminated, then X has a distribution that is more or less mound-shaped and symmetrical. This kind of expression is to tell us that the distribution is normal. So you can use calculator with normal CDF. The mean of the distribution is 2,500 and the standard deviation is 300. A large commercial dairy health inspector takes 42 random samples of the milk produced each day. At the end of the day, the bacteria count in each of the 42 samples is averaged to obtain the sample mean bacteria count. Assuming the milk is not contaminated, what is the distribution of X? The distribution of X bar will be normal because the original distribution was mound-shaped symmetrical. If a distribution is normal, the distribution of sample mean will be normal. Whatever the distribution is, the distribution of sample mean will be approximately normal if the sample size is above 30, like in the case we have here. So even though we have here that this sample mean is exceed 30, but because the original distribution was normal, X bar will be normal. We need the central limit theorem when we don't have information about the original distribution. So this is normal. And then we can use, you can see on the screen here, the mean of the sample mean is 2,500. The mean remains the same. And the standard deviation of the sample mean is standard deviation divided by square root of n, which is 46.3. So it's no more 300, it's now 46.3. So let's look at the question. Assuming that the milk is not contaminated, what is the probability that the average bacterial count for 1 day, let me fix this one. This guy is not, it was the old way of typing. I'm going to change that. Okay. So I was pasting pictures before. When you paste picture, it can move around like it's happened, and then somebody reading might not really understand what it means. What is the probability that the average bacteria count X bar for 1 day is between 2350 and 2650? That's the question. So can you try using your calculator to do that? You have the mean. The mean is 2500. The standard deviation for the sample mean is 46.3. You can see it on that formula. So the lower value is 2350, the upper value is 2650.
0.9988.
Wow. Okay, I was still looking at my calculator. Okay, let's just check your answer. 0.9? Your answer is right. Good. So that is what you do when you have a question about the sample mean. You have to adjust the standard deviation. So we have learned the empirical rule. Let's not forget about that. Empirical rule, you don't need calculator. You have the distribution is within integral addition or subtraction of the standard deviation from the mean. Like we had 600, 700, 800. And then when you have a question about the empirical rule, just go to the PowerPoint or your textbook and look at that design of the empirical rule, and you will know the position of the value that you are given. It is generally 1, 2, 3 standard deviation, 1, 2, 3 standard deviation, and you determine the portion you are asked to answer the question. Okay, would you like us to do some homework problems?
No.
No? Okay, you will try it. Try your homework, and if you have a question, now that we have done it, I can remind you what you should do. Okay? Try doing your homework, and maybe if the homework, you can check the answer. If you are doing well, you just take your last attempt on your quiz.
Okay.
Rachel, thank you very much.
Thank you.
You're
Bye-bye.
welcome. Bye.